Hello everyone, welcome to this session. Today we are going to discuss about the shear force and bending moment diagram in the overhanging beam. In the earlier classes we have solved so many problems for cantilever beam, simply supported beam with point loads and uniformly distributed loads. Today we are going to solve the shear force and bending moment diagram in the overhanging beam, how it acts. What is the difference between the overhanging beam and the simply supported beam? We all know that for overhanging beam, the supports are being in between the two ends. Okay, if both the ends are supported, then we can call it as a simply supported beam if there are two supports. And the same supports being in between the structure of the beam, then that is called a overhanging beam. Okay, now let's move on to the problem solving session. Okay, this is a given problem having supports B and E. These two supports are in between the given beam, so it is called a overhanging beam. So here point load of 10 Newton and 40 Newton are given at point C and at point D. In between A, B we have a uniformly distributed load, so only three loads are being given. One is UDL, two point loads. In connection with these point loads and uniformly distributed load, how the shear force diagram and bending moment diagram will be? That is the question asked. We have to solve. First, we will find out what is the reaction at point B and reaction at E. By using the statical equilibrium equations, we can find out the unknown reactions.
Start.
First, we have to find out the reaction at B and E. So, to find RB and RE, the first aim. For that, you have to use statically equilibrium equations. Equilibrium equation we have to use. We know that sigma V, which is equal to 0. Take upper forces as positive and downward force as negative. Okay, here we have RB and here we have RE at the support. Okay, so we have RB plus RE, which is equal to the total load. Total load is 10 Newton plus 40 Newton plus, and due to this UDL. So UDL is 10 Newton per meter. Let's take for the span of 4 meter. And due to this 10 into 4. So totally we have 10 plus 40, 50 plus 40, 90. The total load is 90 Newton. RB plus IE. Okay. So this is taken as the first equation. If we know one reaction, we can find the another reaction. For that, let's take the sum of another statical equilibrium equation, the sum of moment at any point we can take. So where the support is there, that point we can take it. So let's take the point B. Let's take point B is equal to 0. For that, the sign convention, let's take clockwise as taken as positive bending moment and anti-clockwise taken as negative bending moment. Okay, now all the forces should travel to point B. So here UDL is there, so due to this the point load should travel to B, and 10 Newton travels to B, 40 Newton travels to B, as well as all the loads should travel to the point B, because I am taking the bending moment at point B is equal to 0. Now let's take from this position. So this is a downward load and it acts downward and approaches to the point B as anti-clockwise. So let's take, it is a negative load. Okay. So 10 into 4 into, okay, half of the distance, let's take 2. Okay. So this is the first one, and for 10 Newton it travels to B, okay, clockwise, 40 Newton in the clockwise manner, and this RE in the anti-clockwise, so it is taken as negative. Okay. So this is 10 plus 3, 10 into 3, and 40 into 3 plus 3, okay, 6. Next, this RE is there and it is taken as negative. Okay. Pause. That is a negative RE into total distance 2 plus 1 plus 3, okay, 6 plus 3, 9, that is equal to 0. Okay. So from that, it is a 10 into 4 into 2, that is 80, minus 80 plus this is 30 plus 240, and I can move into that side 9 RE. Okay. Finally 240 plus 30, 270 minus 80, so that is a 190. Okay. 240 plus 30, 270 minus 80, so 190 Newton, that is equal to 9 RE. What will be the RE value? RE equal to 190 divided by 9. Okay. That is equal to 2, 10 means 1 and 3, 0, 30 means 3, 21.03 Newton. Okay. So RE equal to 21.03 Newton. What about RB? So RB equal to 90 minus this one, 90 minus 21.03. So total it is 69.97 Newton. Okay. RB equal to 69.97 Newton. Okay. What is the next step we have to go for? After finding these RB and RE, we have to go for finding the Shear Force diagram. So Shear Force values. How to find the Shear Force values? Shear Force values can be found out by using the methodology to calculate the sum of values of forces with the sign conventions. Okay. For that we have to take right up is positive and right down is negative, as well as left down is positive. Okay. Make it either one thing, right up is positive or left down is positive. Something is opposite to that is taken as the negative value. Okay. Negative shear force values. Okay. Now come to this point here. Okay. Shear force values at from this point. For that reference point we have to take care of it. For this point F, you just take, this is the reference point. It is the reference point for E, reference point for D, a reference point for C, and a reference point for B, and here you don't have any point. Okay, reference point for A. Okay, like that you have to take. First, this point, we don't have any force F at F. Okay, you don't have any force, so it means the shear force value equal to 0. Next it comes to the point F at E. So you will have only one force, that is RE. Okay, we are concentrating from the reference point only right side, so right up is positive, this is upward direction, so this is taken as positive value. What is RE? RE is 21.03. okay, RE equal to 21.03, that is equal to 21.03 Newton. Okay, what about F at D point? So 21.03, this is okay, downward, right side downward is negative, so just make it a subtraction. So finally we will have 19. Okay, that is 18.97 Newton. It is of negative value. Okay, and what about this C point? So 18.97, and just this 10 Newton is negative value, so total it is minus 28.97 Newton. Okay, and what about F at B point? F at B point minus 28.97, and you don't have any load here. Okay, the same value. And what about F at A? F at A equal to 0. Okay, you can consider here. Okay, from the reference point you consider left, there is no force at all. Okay, so shear force at A equal to 0. So these are the shear force values. Now let's draw the shear force diagram. Just take shear force, 0 shear force and neutral line for shear force diagram, SFD. And here we have the point 0, and this is 21.03 positive value, 21.03 Newton T. At D point it is minus 18.97, so come here, so 18.97 Newton. Next minus 28.97, minus 28.97 Newton. Okay, and at B point the same value. Okay, minus 28.97 Newton. At A you have 0. Okay, so how to draw here? Up to B point you don't have any UDL, you have only point loads, so horizontal and vertical lines will be there. So since here it is 0, and here calculate, and it will downward negative line, and here it is same value. Okay, finally minus 28.97 here, and at A point it is 0, but it is of UDL, so you have to draw directly. Okay, so these are the negative values, and the only thing is only negative shear force diagram. Okay, you have only negative shear force diagram. And one more thing we have here, 21.03 Newton is here. Okay, for that here we have done a mistake, so you just go here. Okay, positive. Okay, suddenly it is going towards 90. Okay, so this not will come. Okay, so here you have a positive value. Okay, Next thing is to draw the bending moment diagram. For that, bending moment values are needed. How to find the bending moment? So bending moment to be calculated by having the mathematical expression called force into bending perpendicular distance. So bending moment, let's take as a m is equal to force into perpendicular distance. Okay, so we have points m at f point. Okay, I will tell you just same reference point you have to note down, as well as sign convention I will tell you. This is a positive sign convention. It is nothing but upward force will give you, okay, upward force will give you the positive bending moment, downward force will give you the negative bending moment. So m at f point, you don't have any force here, so it is 0. As well as at this point, okay, at E point you have only one force and lying on the same point, so it does not have produced any bending moment. So m at E also equal to 0. Okay, then m at D point, at the D point you will have only this, due to this RE value you will have a bending moment. So RE into 1 meter. Okay, so what is RE value? RE is equal to 21.03. so 21.03 into 1. So m at D equal to 21.03 Newton meter. That is multiplied by 1. What about m at C point? Here, due to this point, RE into 4 meter and this 40 into 3 meter. Since it is downward, negative bending moment will produce, and due to the upward, you know that it is positive bending moment. So 21.03 into 4, 21.03 into 4, and due to this 40 Newton, it is negative. So 40 into 3 to the point. So this is 84.12 minus 120. So what is the remaining factor is 36, it is 35.88 Newton meter of negative value. Okay, m at C. And let's take what about m at B point? So m at B point, if you consider right side, number of forces are many, 1, 2, 3. You consider left side alone, you have only only UDL. So consider left side from the reference point. Okay, since it is a downward force, 10 into 4 is the total point load and acts exactly at the center point, multiplied with the distance 2 meter. That will be the bending moment, and due to the downward force, negative bending moment will be produced. So the value equal to negative bending moment. So 10 into 4 is a point load and acts exactly at the center point into 2 meter to the point B. So total it is minus 80 Newton meter. This is m at B. Okay. What about m at A? So consider left side, you don't have any force at all. Simply it is 0. Okay. So accordingly you can draw the bending moment diagram. Let's have the bending moment diagram here itself. You just extend here. So m at F. Okay, this is 0 bending moment diagram. M at F equal to 0. M at E also equal to 0. And m at D. M at D point, that is equal to 21.03 positive value, 21.03, it is Newton meter. And m at C equal to, it is minus 35.88, minus means come this side, okay, minus 35.88 Newton meter. And what about m at B? It is of 80. Okay, that is negative value. Okay, 8 Newton meter. And finally m at A equal to 0. Now when there is no UDL at all, you just draw the direct joining of 2 point values. Okay, so 0 to 0 direct joining, and B to C, E to D, this point joined directly, linear line, and this point to, it is negative value 35.88. Okay, negative value, and here to here UDL, it is of linear line, and B to A, here B to A you have UDL, so you should have a not a linear line, it is a cubic line. Okay, cubic line, so sorry, parabolic curve, it is a parabolic curve. Parabolic curve, it is of linear, everything is linear other than that. Okay, so this is the negative and this is positive. Okay, so this is the bending moment diagram, and this is the shear force diagram. For this is a shear force and bending moment diagram for the given overhanging beam. Okay, so that's all in this session. We will have another set of that is overhanging beam problem, which you will have the point of counter flexure oriented problem in the next class. Okay, thank you.